Hello there, mathematicians. Today's objective is 120C, and that is students will be able to perform rate conversions. Get that down. Alright, we are going to come back to the steps. Again, I don't like just giving steps and saying, hey, memorize these, because let's face it, we don't just memorize them. I want you to understand how to do things. So we're going to hop right in to examples. Okay, here is the first example. Take a second to read this. This is the one in your notes. Okay. Really the most important thing about this objective is learning to identify the type of problem that it is, and knowing that and seeing that these types of problems are just a little bit different than the 120B problems, just the unit conversions. Okay. Now, I want you thinking right now, how are they different? What in the wording and numbers tells you that they're different? Okay. Here's the issue. Before, it would just say something like the 120B problems would say something like convert 300 meters to feet. So you're going from meters to feet, one unit to another. Okay. But if we look at this problem, we have meters per hour to feet per second. So we actually need to convert our, we have two different types of units in here. We have one that measures length, so we need to go from meters to feet. And then we have another one that measures time, so hours to seconds. Okay, so we have basically two different unit conversions that we got to do together, meters to feet and hours per second. Again, 120B is just one, where it's just like, oh, convert hours to seconds. That's it. Okay. Now, one of the things that is kind of a giveaway on this is the word per. Okay. This shows a relationship, and we typically show per with division. Okay. So, we're going to follow the exact same steps as yesterday. Okay. So, the very first step was we need to make a roadmap. Now, with this one, we're going to have two different roadmaps. So I'm going to draw out a roadmap. Now I'm going to start. Okay, I started with meters. Okay. Now, what is meters being converted to? Is it being converted to hours? Okay, the answer is no, because meters measures length and hours measures time. You can't convert those. Okay, is meters being converted to seconds? Answer, no, because again, that's time. Meters is being converted to feet. So it's important that we recognize, okay, where are we starting at and where are we ending? Starting with meters, going to feet. Okay, and then the other conversion that we need to do is hours to seconds. Okay, now we have to ask ourselves, do we need to make any pit stops? So, do you know the relationship, the conversion between meters and feet? And the answer should be yes. You should know that. Okay? If you don't know that exact conversion, make sure you look back. Now, the meters is in the metric system. Feet is in the U.S. standard or customary. So you need to look at page 2 of your notes, because that's the conversions between the two units. And you have to memorize that conversion. You got to know that one. Okay? Hours to seconds. Do you know how many seconds are in an hour? Okay, most likely no. You might have started to memorize this by now because you've done a few of them. Okay, but we need to stop after hours. We would stop at what? We would stop at minutes. Now, write out MIN, because if you just write M, that actually stands for meters. You don't want to get those mixed up. Okay, all right. Now let's write our conversions. Okay. Starting with meters. So, again, you should know this. 0.3048 meters is equivalent to 1 foot. Okay? And then we have hours to minutes. So, we're just going to write out all these conversions, all the relationships. 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. Again, use your roadmap to help you fill that out. Okay. Now, yesterday, we would be given something like 300 meters converted to feet. So we would write out, okay, 300 meters, and then yesterday we would put it over 1, right, because that was it. Well, this is different. 300 meters per hour. That per tells us the fraction bar. And now instead of just having 1 in the denominator, it's actually hour, or 1 hour. And again, we know it's 1 because it just says per hour, so we assume it's just 1 hour. Okay. So another difference between yesterday's objective and this one is that we have units in the denominator because of this word per. Shows that fractional relationship. Okay? Alright. Now, here's kind of the tricky part. We need to cancel both meters and hours. Okay? We are only going to focus on canceling one at a time. Okay? I always like to start by canceling whatever units are in the numerator here. So let's cancel our meters. How do we cancel meters? We want to get rid of it. Well, if meters is in the numerator, the top, we need meters in the denominator. Again, you guys should be saying these things with me as I teach them. Okay, then we simply look at our roadmap. After meters, we said that we were going to feet. So, I need feet in the numerator. Now, feet is what we wanted, right? We wanted feet, so we can circle it and stop. Now, are we done with all of our conversions yet? And the answer is no. So we're not going to write the equal to sign because we still got to get rid of hours. All right? So I need to keep multiplying by fractions. So now that we canceled our meters and we have our feet, now we simply go back and look at, okay, well, how do I cancel my hours? Because again, now we have to convert two different things. Well, where's hours at? Hours is where? In the denominator. So where would I need hours in this fraction in order to cancel? I would need hours in the numerator. Okay? Again, we just look back. We already canceled our meters. So now I need to go back and say, oh, I just need to cancel my hours. How do I do that? Hours is in the bottom, so I need hours in the numerator here. Okay? Look at your roadmap. After hours, we said we were going to minutes. Okay? Now, do we want to stop at minutes? The answer, no. How do we cancel minutes? Well, minutes is in the denominator, so we need minutes in the numerator. Okay? What do we go to next? We said we were going to seconds. Okay? That is what we want. So now, if you look at this, we wanted feet per second. We have feet in the numerator. We have seconds in the denominator. That will end up with feet over seconds, which is feet per second. So we can write our equal to sign. Now we're going to fill in numbers. The 0.3048 goes with the m, so it goes in the denominator. 0.3048 meters is equivalent to 1 foot. There are 60 minutes in 1 hour. There are 60 seconds in 1 minute. Okay. So now all we have to do is multiply all the numbers in the numerator. Okay, so 300 times 1 times 1 times 1. You had better know that, and you had better not be using a calculator. 300, don't forget your units. Oh, we forgot to cancel. So hours in the bottom, hours in top cancels. Minutes in the denominator, minutes in the numerator cancels. So we have 300 feet over, you simply multiply 1 times 0.3048 times 60 times 60. And I believe we get, for the denominator, 1,097.28 seconds. Okay. Now, you don't want to leave your answer like that, so you need to divide those. Now just do 300 divided by 1,097.28. Okay. And I believe you get something like 0.2734, and it goes on. Is that a rational or irrational number? Does it look like the decimal repeats? Okay. It may not. I tried to kind of trick you on that. It may not look like it repeats, but is 300 a rational number? Yes, it is. Is 1097.28 a rational number? Yes, it is, because the decimal terminates. Whenever you divide a rational by a rational, you get a rational number. Okay, so it is a rational number, even though it doesn't look like the decimal repeats. It actually will repeat just a long way down the road. All right, let's kind of establish a rule. Let's round to the nearest hundredth. Okay, so if you ever have a problem in this objective, let's round to the nearest hundredth. Okay, so 10th, 100th, we underline the place value, draw an arrow next door. Ask set number, are you bigger than 4? The answer, no it is not. So, our final answer, it don't grow. So 0.27, don't forget the units. It is feet per second. Okay, and this would be our answer. Okay, all right, go back, spend the time, look at how we set that up. Okay, look at where we put the units, look at how we did each step. Again, very similar steps to yesterday. In fact, the exact same. We just kind of have a little bit of extra work with it. But if you understand yesterday's, you'll be in good shape for today's. Okay. If you have any questions, you need to do something in your notes where it's like, why, and you don't need to write this unless this is your question, like why am here. Okay. That way when you get to class, you can ask teammates. All right. Okay, let's take a look at example 2. 4,000 cups per week, 2 gallons per day. All right. First thing again, think about what type of problem is this? Okay. How many different conversions do we need to do? Okay, well, we need to do 2 different conversions, right? We need to go, okay, cups measures capacity, so we need to go from cups to gallons. We need to go weeks measures time, so we need to go from weeks per day. All right, so again, first step is what? Should have said roadmap. Okay, so we're starting off with cups, and we're going to, what are we going to? Gallons. Again, if you said weeks or days, cups measures capacity, weeks and days measure time. We can't make that conversion. Okay, and then we also need to go from weeks to days. Okay. Once you have your roadmap, you simply ask yourself, well, do I need to make any pit stops? Do you know the relationship between cups and gallons? And you should. Okay, remember we use that graphic organizer to help us with cups, pints, gallons, and quarts and all that. Okay, do you know the relationship between weeks and days? You're in high school, you better. All right, so right now I want you to identify how many cups is equivalent to how many gallons. Okay. If you don't know that, hit pause, picture that graphic organizer. Do that now, write in your own answer, make sure you're using pencil. Okay. You should have said 16 cups is equivalent to 1 gallon. Okay. And then we have 1 week is equal to 7 days. All right, let's set this up. Okay, this first thing is our starting point, right? That's our starting point. So that's our first fraction. We have 4,000 cups per fraction bar week, so we assume it's 1 week because it's singular. Okay? All right. Again, we can only cancel one of these at a time. Let's start with the top unit, which is the cups. How do you cancel cups in the numerator? You need cups in the denominator. Okay. After cups, we said we were going to gallons times. Okay. Now, I want you guys thinking, what do you do next? What do you do next? First of all, these cups canceled. We got our gallons that we want. All right. So now we need to cancel. We need to convert our weeks. Well, if weeks is in the denominator, where does weeks go in this next fraction? Okay, you should have said weeks has to go in the numerator in order for it to cancel. And then after weeks, so the question is, what do we fill in the bottom for units? Look at your roadmap. That's why we make the roadmap. We had days. Days is what we want. That's what we want the final answer to be. So now we're going to have gallons per fraction bar day. Okay, again, we can even write this out here. We're going to add up with gallons in the numerator, day in the denominator, so that ends up being gallons per day. Now we can fill in our units. Oh, let's cancel our weeks here. There were 16 cups in 1 gallon, and there are 7 days in 1 week. Okay? Alright, so now you can multiply across, and you end up with 4,000. 16 times 7, that's 112. Okay. Do you leave that answer? The answer, no, you need to divide it, right? When you divide it, you end up with 35.714. And that decimal does keep going, but I already know that I'm going to round. Remember, I said we're going to round to the nearest hundredth. Okay, so underline the place value. Draw an arrow next door. Ask that number. Okay, you should have said that. Ask that number, are you bigger than 4? Is 4 bigger than 4? The answer, no. So, what happens? How does the rap go? So, it don't grow. And remember, we're always talking about the one that we underlined, the hundredths. So the answer on this would be 35.71. And then don't forget your units, gallons per day. Okay. We are still making way too many mistakes on rounding, so we have got to get that down. Okay. All right. Let's do another example. Okay. This is example 3. I'm going to have you guys do each step, and then on your own, make sure you're using a pencil, and then you're going to check each step with me. Okay. So right now, I only want you doing the first step only, okay? So do it, hit pause, do it, and then once you have that first step only, unpause it and check your work with mine. Go ahead and hit pause now. Okay. You should have, for the first step, identified that this is a meters per hour to centimeters per second, which means we have 2 conversions to do. And I think it's a good idea to just write that 2 conversions, because one of the toughest parts for students on tests is identifying the type of problem it is. Alright, so the first step is a roadmap. We started off with meters, and we're going to centimeters. We started off for time with hours, and we're going to seconds. Okay. Now, if you did not consider pit stops, make sure you hit pause now and consider any pit stops that you need. Alright, so pit stops. We can use, so meters to centimeters, right? Those are both in what system? They're both in the metric system. So because they're both in the metric system, we can use King Henry to make that conversion, and we don't need to make any pit stops. Okay, and we'll do that in a second. Alright, the next step, hours to seconds. Do we need to make a pit stop? Yep, we should stop at minutes. Okay. Alright, do the next step, which is the relationship with the numbers. So what are those conversion factors between meters and centimeters, hours, minutes, and seconds, okay? So hit pause now, write out those numbers, those conversions. Okay, for King Henry, okay, King Henry died unexpectedly drinking chunky milk. Alright. We need to know, we're basically starting with meters, right? Where are meters at? Meters are under the base units. Remember, meter, liter, gram. Okay. We essentially want to know, if we have 1 meter, how many centimeters would that be? Okay. Again, if we had 1 meter, how many centimeters would that be? Well, 1, 2 steps. So we would need to move the decimal 2 places. So 1, 2. Okay. So here's the conversion. 1 meter, again, if we had 1 meter, would be equivalent to 100 centimeters. Alright? Now, this is actually something that you should really memorize. If you picture a meter stick, which is about the same length as a yardstick, okay, there are 100 little centimeters within that 1 meter stick. Again, that's something that you should probably just memorize for science, for math, both this year and in future years. Okay, so that's our conversion factor for meters to centimeters. Now we need the 1 hour is equal to 60 minutes. Okay, and then 1 minute is equal to 60 seconds. All right. The next step that I want you to do is go ahead and do this quickly. Write out what your first fraction is. Again, write out what your first fraction is. If you're not done with that, hit pause now. Okay, so your first fraction is 4 meters per hour, so 1 hour. Okay, all I want you doing for this next step is I want you writing in the fractions with units only, okay, and cancel out the units that cancel. Do not write in the numbers yet. So hit pause, write in the units only now. Okay, you should have the units down. Again, I want to push you. If you did not take the time to do that, okay, and you're just watching it, you are really, really, really hurting your learning, okay, and this is a really tough objective. All right, so you guys have to start making those little decisions now that help your learning. All right, so meters in the numerator, we need meters in the denominator. After meters, we said we were going to centimeters according to our roadmap. So meters cancels, leaving us with centimeters, which is what we wanted in our answer, centimeters. Okay. Hours is in the denominator, so therefore I need hours in the numerator. After hours comes minutes in our roadmap. Okay. And then to cancel minutes, I need minutes in the numerator. And then seconds will be in the denominator. That's what I wanted. Okay. Hours cancels. Minutes cancel. Minutes on bottom, minutes on top, cancel out. Okay. If you had something wrong on that, you need to make a note now about, if you had like centimeters in the denominator here, okay, you need to make a note on this, a question like YM, okay, question mark that, and do it in a pen or something. That way when you get to class, you can ask a teammate right away, and they can help explain it to you. Okay. Now, you're going to hit pause and fill in the numbers for all of these conversions. So hit pause and do that now. Okay. Your numbers should be, and again, we have it right up here. This is why we do this. 1 meter is equal to 100 centimeters. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. Okay. Now go ahead and multiply across, write in your number. This should be easy. 4 times 100 is 400. Don't forget your centimeters. Over 6 times 6 is 36. Add the 2 zeros, 3600. That's a 6 there. Okay. And then seconds. And then go ahead and divide. Okay, and you get 0.1 repeating. Now, you may ask yourself, should I round this to the nearest hundredth, or should I leave it as 0.1 repeating? Okay. Whenever you can write an exact answer, so like if the decimal is repeating, keep that exact answer. Again, in math, we want to be as exact as possible. We only round when we need to. So if the decimal goes on and on, okay, sometimes we need to round just to make sure that we can understand the answer. But if it's 0.1 repeating, keep the exact answer. There's no need to round that. So 0.1 repeating, bar above it, centimeters per second would be your final answer. Okay? All right, we will obviously practice more of these in class. I'll tell you what, before you get to class, I want you to do example 4 on your own. Make sure you use a pencil and do example 4 on your own. Again, that must be done before you get to class. And your work should look exactly like mine. Each step shown, conversions, units canceled, everything the same. Okay?